Hi there. We are going to do some numerical simulations with visual debugging, with very simple visual debugging actually, with my own library, which I'm going to present you and advertise for you. So let's make convenient X-term with large font, and we are TMP folder, which is nice. Let's create a single source file, touch test cpp. Perfect naming for everything, right? So let's open it in gedit test cpp. First stream goes to nowhere, second stream goes to nowhere. Nice. And we have yes, we have highlighting. Great. I'm going to create a vector of some data which will be real. I will define it as say double. We are going to model, let's say, a thermal conductivity problem, and so our main field will be temperature, so the perfect naming will be, of course, A for it. So it will be an X by N Y size, rectangular sort of matrix, rectangular field of data, and we need to include vector, and it's time to fill it up. We need to introduce an X. An X is 133 and an Y is 111, and here goes our nested loop for J from 0 to NY, and for I you got it, from 0 to NX. Alright, cool. And now let me introduce convenience variables X and Y, which will be real I divided by real NX. The same thing for Y. And now goes r squared, which is a distance from some point somewhere in our box, centered in, so it will be a bump of temperature centered in 0.3, 0.4, and r squared will be, of course, x by x, y by y, and we are going to use the simplest formula for our temperature field. We are going to use the most natural addressing, and the simplest formula will look like this, R2. So our little bump is ready, or not little, we will see further. It's time to do some numerical steps. So we are going to make a loop for our steps. The step will be named K. 333 steps will be done, and now I'm going to calculate the value which corresponds to the difference which we are going to add to our temperature field according to the simplest Euler scheme, and the difference should be stored in a separate array. Of course, it will be dA. We need to put zeros here because we are going to set this array just in the not for the whole box, because when we are setting DA, the index is here, we are going when we are setting DA, we are using 5-point scheme for Laplacian, so we are using neighbors, and that's why we are going to use smaller range in our loops, just to be in the box, not to go outside the box and have some segfolds or something. Even worse may happen, actually. So we are going 4 values in the center with negative sign, and with the positive signs will be 4 neighbors. Left neighbor, no way, I need to copy it, of course. A right neighbor, bottom neighbor, and the last one is top neighbor. No. Okay, we are done. Now we need to apply our DA to A. A is equal to DA. DA multiplied by DT, and we need to choose some value for DT. It should be some small value, because it should be safe for our non-stable Euler scheme. Oh, return 0, of course. That's a crucial thing. Return what? Return. Good. I hope it builds. Wait, where is my xterm? That's my xterm. Cool. No 3. Test CPP. I'm pretty sure it will work fine. Cool, it works, right? Now let me use my library. We need to see what's going on, right? Include simple draw. This is a typical library with a header file, of course. So we are going to include it, and we are starting to use it right away. No, not here, right here. Fadey init. That's the perfect naming for the function of the homebrew library, because my name is Fadey. It's a nickname, right? Perfect naming. Fadey init is a library which creates a window in a separate thread, which you can use while you are calculating or while calculation is stopped. The window is alive every time in a separate thread. Super convenient. So in the init function we are setting nx and ny, and I'm setting some garbage values here because I can change it anytime I want when I draw. And the last parameter is number of tiles. This parameter I can't change during calculations, so I'm setting 2 here because we have just A and DA, nothing more. So we are ready to draw something. Let's do it. Fadey draw. Draw. And I need a pointer to a floating point value, which is double in this case. So I'm using a.data, right? Then goes geometry and x and y, and then goes the tile number, which I'm gonna use. So with this function I'm drawing the initial value, right? Now I want to draw on each step. I want to draw initial. I want to draw a temperature, and I want to draw a DA. DA will be drawn to the second tile. That's it. And I will call function fd close. Of course you don't need it, but and you will never use it, I know, but I will use it because it's my library, which I love very much, of course, and I will do a clean exit, of course. Let's start it. No, it doesn't compile, of course it doesn't compile, because I need to specify where to find include files, simpledraw2D. Now it compiles, but it doesn't link. Of course it doesn't link. To make it link, I have a static library, yeah, so I'm just using it. Home, then simpledraw2D lib simpledraw2D a. Cool. Wait, what? Aha, that's right, because the order matters when you use static libraries. So I'm changing the order. The CPP goes first and then goes my library. Now it's better. It's complained about something else. It's actually just OpenGL, LGL. Good, it works. It was just very fast. And now there goes some inconvenience because something happened, but we didn't notice it. Because sizes of arrays are, you see, very small, 100 by 100, and 300 steps. It's just a fraction of a second. So I need to stop it somehow. I'm using fd halt for it. Halt. This function sets a flag, which actually changes the behavior of draw function. So after halt is called, next draw function will be stopped. So what I expect now is that just after the first draw command, my numerical simulation will be stopped by my window in the separate thread will be perfectly fine, and I can explore my data. Look what happens now. Yeah, it's alive. I can use it. I can explore my data. I can zoom in, zoom out, pan, and do some cross sections. Everything works, and I even can change the size of the window. Nevertheless, it's just a homebrew library. I can do everything. Isn't it cool? That's cool. That's really cool. But my bump is very big. Let's change the bump. Let's make it smaller. And we run, and now it's smaller. I will change. I'm in a halt mode, and I can do steps now. Using S key on the keyboard, I can do steps. 1, 2, 3, 4. Something is wrong. You see, something is wrong, and that's because I'm not updating A. I'm just setting A to be equal to DA. That was the problem. Of course. Now I'm trying it again, and yeah, it works. I'm just doing one drawing command each time I'm using S key. So each time I'm pressing S, I'm doing just sort of a half step. So to make one step, I need to press 2, and now I see count is equal to 2, and each time I press S, it allows me to make 2 draw commands. So that's how I can do one numerical step per pressing S key. Let's make some more. Oh, no, I'm deleting the value and pressing 1, 6, which is 16 steps. Now I am making 16 draw each time I press S, which is just 8 numerical steps. Okay, it works. I hope it works. Yeah, it works, because temperature spreads all over my bounding box. Okay, it just stopped. What else I can do with this? Actually, very interesting things. I can do really interesting things with this tool. Look, now I'm going to make 2 steps. Each time I press S key, I'm making 1 step. And now I can just press and hold D key on my keyboard. Everything become red, and now I can use the wheel to make my painting tool bigger. Guess what? I can grab the value and paint here. I can paint here. I'm a bit nervous, and that's why it's shapeless, but I want to make some funny alien Pac-Man. To do so, I need also grab some smaller value and make 3 eyes here and a smile. Looks nice, I think. So what I did, actually I painted on my picture, but this picture is drawn using pointer to my data. So the library itself inside, it draws not only to a picture, but it actually draws to the actual data, and then it just shows that data as a picture. So I changed my data. I really changed the numerical data, and now when I'm trying to make next step, you can see that it's an actual data, and it changes. It starts to melt. It's melting like a snowman. So sad. Let's do some more steps. It's melting. It's thermalizing, which is the same as melting. That's it. Nice, isn't it? So do you want to use that? Of course you want. Of course you want. You wanted to copy me and do exactly like I did. Try OpenGL and get screwed up worse than my life is. No, you don't want to do that. You want just no, you also don't need that. You need my library. To get my library, which is MIT licensed, so you can do everything you want with it. You can go to GitHub page. Here it is. Read through the documentation, clone it, build it on Linux, build it on Windows, study the test cases, CPP test cases, Python test cases. Yes, it works for Python, you know. It also works for Fortran, and it even works for some vintage, some really ancient versions of CPP and Fortran. And you can draw your data like me. Isn't it nice? So yeah, have a really nice visual debugging of your codes. But let me add just one more thing. As you can see, where is my library? Here it is. As you can see, the output is quite crappy. It doesn't have axis. You see, there is no axis here. There is no color bars. There is no aspects, right? See, aspect changes, and you never know how your data looks like. So please never use it for publishing. That's a not appropriate tool for publishing. It's a tool just for you, just for your collaborators, for a live collaboration, where you should clearly state where is what tiles correspond to which physical entity, or not physical, to any entity that you're trying to simulate. And you need to tell where is X and where is Y basically. So that's of high importance. And if you want to publish, please use appropriate software. Use MathGL, use Asymptote, use Matplotlib. You can see this list in the description. It's really nice tools for publishing, and it's actually perfect, while this tool is just for debugging. So have a nice time with publishing, have a nice time with debugging. Bye.